What are common challenges in programming error diagnosis? Have you ever found yourself stuck trying to figure out why your code isn't working? You're not alone. Let's talk about some common challenges that programmers face when diagnosing errors in their code. First, there are different types of errors that can pop up. Syntax errors are the easiest to spot. These occur when the code breaks the rules of the programming language, like forgetting a semicolon or having unmatched brackets. Most of the time, compilers or interpreters catch these before the program even runs. Then we have runtime errors. These happen while the program is running, like trying to divide by 0 or accessing an invalid index in an array. These can be tricky because they depend on specific inputs or conditions, making them harder to catch. The most challenging type of error is the logical error. This is when the program runs without crashing but gives incorrect results. These errors often come from mistakes in the algorithm or wrong assumptions about how the code should work. For instance, using the wrong comparison operator or making off-by-one errors in loops can lead to unexpected outcomes. As software becomes larger and more complex, understanding how different parts of the code interact can be tough. This complexity makes it harder to trace the source of an error, especially when multiple modules or external libraries are involved. Another challenge is insufficient or ambiguous error information. Sometimes, error messages are vague, making it difficult to pinpoint the exact cause of the problem. Some runtime errors might only show up under rare conditions, complicating the process of reproducing and diagnosing them. Poor documentation can also be a hurdle. If the code lacks clear explanations about its behavior, expected inputs, and outputs, it can lead to confusion and longer debugging sessions. Environment and configuration issues can create errors too. Differences between development, testing, and production environments, such as mismatched software versions or missing dependencies, can lead to unexpected behavior. Some errors are hard to reproduce. They might occur only intermittently or under specific conditions, like timing issues or problems in multi-threaded programs. This unpredictability can make diagnosing the issue even more frustrating. Lastly, cognitive bias can play a role. Programmers might overlook errors because they assume the code works a certain way. This can lead to missed bugs or misinterpretation of the symptoms. To tackle these challenges, there are practical approaches you can take. Using debugging tools that allow you to execute code step by step and inspect variables can help you understand program behavior better. Writing and maintaining automated tests can catch logical errors early and ensure that new changes do not introduce additional bugs. Code reviews can provide fresh perspectives and help spot errors that the original coder might have missed. Adding assertions in your code can verify assumptions and catch unexpected states during execution. Keeping documentation clear and updated can clarify the purpose of the code and its expected behavior. Finally, try to reproduce bugs in controlled environments to isolate their causes and test fixes reliably. By understanding these common challenges and applying systematic debugging techniques, you can improve your efficiency in diagnosing programming errors and fixing bugs effectively.